Now that we know what the expectation of the discrete random variable is, let's talk about three properties that you need to know. The expectation of a constant is the constant. Where a is a constant, we can say the expected value of a constant is the constant of itself. The expected value of 5 is 5. The expected value of 3 is 3. The expected value of 27 is 27, because 27 doesn't vary. The expected value of some constant times our discrete random variable is, I can just pop this a, this constant, out in front. So the expected value of 4 times my discrete random variable is 4 of my expected values. So that's an important concept to know, is that we can pull this a out in front. And last but not least, the expected value of some function of our discrete random variable is, well, here I just had xi, but now I've added in the function value. So all we have to do is, again, we're going from I equals 1 to I equals n of xi times the probability that our discrete random variable is equal to that x, some I. I don't know what I it is, but it's just some variable I. But we're going to take the function value and multiply it by the probability of each of the values of the function. So there's just one extra step when we have a function of the discrete random variable. We're going to take the function of the individual x. Let's do some examples. Okay, let's do some examples with properties of the expectation. First, for this probability distribution of my discrete random variable, x, which can take on the values 0, 1, 2, or 3, I need to first find the expectation, which is simple. It's 0 times 1/6 plus 1 times 1/2 plus 2 times 1/5 plus 3 times 2 over 15, which when I do that all out, I get an answer of 1.3. There is my answer for the expected value of x. Well, expected value of 2x, we know that EAX is equal to AEX. That's what we learned in our last slide. So that allows me to simply say, well, this is going to be 2 times E of the x, which is 2 times 1.3, which is times like that, which will give me 2.6. And finally, I can do something like this. I can find E, the expected value of x squared. Well, what would that require me to do? Well, in this part here, I had x times its probability. The probabilities will remain the same: 1/6, 1/2, 1/5, and 2 over 15. But now my x values are going to be squared. So it'll be 0 squared times 1/6 plus 1 squared times 1/2 plus 2 squared times 1/5 plus, last but not least, 3 squared times 2 over 15. This is saying take the x value and square it before you multiply it by the probabilities. And when you do that, you get 2.5. I will save you the work there, but it's just a matter of plugging that into your calculator or using old-fashioned math. Here is a small but important point. In our last slide, we found that the expectation of x squared was 2.5. How do we find that? Well, we had to square this and multiply by this, square this, multiply by that, square this, multiply by this, square this, multiply by this. And we found EX squared equals 2.5. We found originally that EX is 1.3. Well, what is EX squared? The whole thing squared will be 1.3 squared. I just substitute 1.3 in there, which gives me 1.69. Now you'll notice the most important thing about this part here is that EX squared does not equal EX, the whole thing squared. Here we had to square the individual values before we multiplied by the probability. And here we took our expected value and we squared it. And they weren't equal to each other. That's going to be important in our next section when we talk about variance. Here's an example of the expectation with the function. Again, I have that same expectation. The discrete random variable can take on values from 0 to 3, and here are the probabilities associated with each of the values. It's quite easy to find E of x, the expectation value, but now let's find E of a function, x squared plus 3x minus 1. Well, all that means I have to do is I'm going to use the same thought pattern I had before. The sum of I equals, my lowest value is 0, my highest value is 3. Of what? The function of x squared plus 3x minus 1 times the probability that x equals a particular x. So I've got to take our values and put them in this function. Let's take 0. 0 plus 0 minus 1. When I plug in a 0 there, I get minus 1 times the probability. Plus, if I put in a 1, 1 plus 3 minus 1 is 3 times the probability of 1/2. Now, if I plug in a 2, I get a 2 squared plus 3 times 2 minus 1 is 9 times 1/5. Now if I plug in a 3, 3 squared plus 3 times 3 minus 1 is 17 times that same probability. The only thing different is instead of just plugging in a 0 and a 1 and a 2 and a 3, notice those numbers are different. What I first had to do was plug these values into my function here. From my function, if I plug in a 0 to this, I get a -1. I'm going to now multiply that function value times the individual probabilities. And when I expand this all out, when I do the math here, I'll get an answer of 5.4. That's my expected value of this function. One last property of the expectation. We saw that the expected value of a constant is the constant. We saw that the expected value of a constant times our discrete random variable means just pull out that a in front. We saw that the expected value of a function is, instead of having an x, we take f of x times the same probabilities. Well, here's that last one. E of ax plus b. Turns out that that is aex plus b. So the expected value of ax plus b turns out to take this a out front, that's a constant, times the expected value, and then we're going to have the whole thing plus b. I couldn't find a good example of that with you, so maybe it's not super important for us, but it's just good to know this and file away. You may need it someday.